Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Module 3, Lesson 9, Basic Properties of Similarity. All right, so we're going to start with the classwork here. And the exploratory challenge says, now when it says exploratory challenge, that means you're supposed to try it on your own. So pause the video, see if you can do it, and then come back and we'll take a look at it. So here now says the goal is to show that if triangle ABC, which is over here, the larger one, is similar to the triangle A prime, B prime, C prime, which is here, then A prime, B prime, C prime is similar to triangle ABC. Symbolically, if the first is similar to the second, then the second is similar to the first. So A, first determine whether or not triangle ABC is in fact similar to triangle A prime, B prime, C prime. If it isn't, no further works need to be done. Use a protractor to verify that the corresponding angles are congruent and that the ratios of the corresponding sides are equal to some scale factor. Okay, so the first thing I'm going to do is the scale factor portion. So I'm just going to move this up to here. Actually, let me change my view so I can see more. And I am going to calculate my scale factor all 3 times. So what I need to do in that situation is compare what we had to do to get from the small one, or the big one, down to the small one. So it's scaling down, so my R has to be less than 1. So in order for it to be less than 1, the number on the numerator has to be smaller than the denominator, so I want to put my primes on top. So I'm going to start with that. A prime B prime over AB equals, and A prime B prime is 2, and AB is 4. Well, that reduces to 1/2. So there's my R. R equals 1/2. Now I need to confirm that my R is going to be the same for all 3. So now I'm going to check B prime C prime divided by BC. And B prime C prime is 3. And BC is 6. And 3 divided by 6 reduces to 1/2. And then finally, I need to see that A prime C prime over AC is going to be the same as these other 2. So A prime C prime is 4. The length of AC is 8. And 4 over 8 reduces to 1/2. So I got 1/2, 1/2, 1/2. So I can confirm that my scale factor is 1/2. Okay, so it also says to take a protractor and use it to measure the angles. Now yours is going to be different than mine because when I scaled that up, down, and then the projector, the program will manipulate this a little bit, so your values may be off a little compared to mine. So I'm going to put my protractor on, so right on that line, so I've got 0 lined up. So I'm checking the measure of angle B right now, and when I do that, then I want to move this over so it's going through A, and it looks like it's about 81 degrees. So I'm going to write that over here. The measure of angle B equals 81 degrees. Okay, now I'm going to move my protractor down. How about we measure A? So I'll put the vertex right there. Rotate until I'm right on the line C here, and then this has to get rotated around actually. So if I have that as AB right here and move this to AC like so, then I can look at the angle measure. Now it's acute, so it's got to be less than 90, so I'm looking inside here, and it looks like it's 1 degree less than 50, or 49 degrees. So now I'm going to call the measure of angle A 49 degrees. Now I'm not going to measure angle C. I'm going to use a theorem that we learned this year, the triangle sum theorem. And there's 180 degrees in a triangle. So if I just simply add these two, I get 130 degrees. Well, I need another 50 to make 180. So now I know measure of angle C must be 50 degrees. So I'm just going to get rid of that and write that. The measure of angle C equals 50 degrees. Okay, now I'm going to do the same. So since my protractor is already set up for angle A and I just move this over here, I need to put this at A here and do a rotation, and that blue line should land on the side that we're measuring. So if I move this all the way over to here so that AB's on that line 0, and sure enough this is going right up to C, that it confirms that my angle A is also 49 degrees, A prime. And this is how I'll write it. The measure of angle A equals 49 degrees, which also equals the measure of angle A prime. So the measure of angle A equals the measure of angle A prime. If A equals B and B equals C, then A equals C. That's the transitive property. Okay. And then I'm going to do the same with B. So if I put my compass, or my protractor, I mean, on B prime, like so, and rotate this so it's right on AB, and move this over to C, then that is 81 degrees. Okay, so that is also B prime. So equals the measure of angle B prime. And since those two are equal, then this has to be equal to the measure of angle C prime. So what we have just done was confirmed our scale factor and confirmed that the angles are congruent in both triangles, and therefore the two triangles are similar. And of course, if I scale this down by a half to get here, or if I scale this up by 2 to get here, then that proves that if one triangle is similar to the other has to be similar to the first. Okay, it just goes to show. All right, B, describe the sequence of dilation followed by congruence that proves they are similar. Now they want us to map one to the other. So let me get rid of this. Okay, so now they want us to move this stuff around. Okay, so this is just doing what we did in lesson 8. But did they say what we should do first? Describe a sequence of dilation followed by. So we want to dilate first and then sequence of dilation followed by a congruence. Okay. Followed by a congruence. Okay. So what I'm going to do here is, first of all, I'm going to dilate it. So from the first thing I'm going to do is identify my coordinates, and C prime is at 4, 9. B prime is at 5, 6. And A prime is at 3, 5. Okay. Now my scale factor to get from the big triangle down to the small was a half. So to go the other way, we take the reciprocal of this. So I want R to equal 2. So if I multiply 2 times C prime, it is going to equal C. And 2 times C prime is going to equal C. And 2 times 4 is 8. And 9 times 2 is 18. Okay, so when I do this, that will scale this up, and it is going to be way off the paper. All right, so in this situation, there's no way for me to graph that and then move it. So I'm going to pause there, and I'm going to think of another way to do this. Okay, so in math, sometimes we have to practice or try a couple of things until we come to a realization of what would be the best procedure. So how about we dilate this down and then move it to see if this is similar to this, because order doesn't matter now. We just realized that if one is similar to this, and this is similar to this, so I can go either direction. I can make this bigger and then move it here, or I can make this one smaller and move it over to here. So let's make this triangle smaller. So A is at -4, 6. B is at -8, 4. And C is at -6, -2. So now if I say the scale factor of 2 times A is going to give me A prime, and my A is -4, 6, then my A prime is going to end up being -8, 12. Okay? Oh, we're going the other way. My apologies. So it's a half and a half. Okay? So I use the same scale factor. I want to use this scale factor here because we're going big to small. So half of -4 is -2, and half of 6 is 3. So my A prime is going to end up at -2, 3. So I'm going to put a dot right there, and I'm going to label it A prime. So this point here, moving towards the origin halfway, would be there, because if we pictured a ray going through, then it would be right there. Okay, so the next one we're going to do is 1/2 times B is going to equal B prime. 1/2 times the point B, which is -8, 4, is going to equal B prime. And 1/2 of -8 is -4, and 1/2 of 4 is 2. And so my B prime is -4, 2, which is right here. And that is B prime. Okay, so now we're going to do C. 1/2 of C equals C prime. 1/2 of the point C, which is -6, -2, is going to equal C prime. Then 1/2 of -6 is -3, and 1/2 of -2 is -1, and that's where my C prime is going to be. -3, -1, which is right here, and that is C prime. Okay, just to save you pain and anguish, I paused the video, I drew my straight lines here. Now I'm going to move it. Okay, so now we have to determine where to move this. So I have to move A prime over to here. And A prime is now at -2, 3. And it's going to end up at the point 3, 5. So my x, y is going to become x moving to the right 1, 2, 3, 4, 5. -2 to 3 is a distance of a +5. And then y, then we're going to move it up 2. So I'm going to move my x, y, my whole triangle, to the right 5 and up 2. So if I do that, 1, 2, 3, 4, 5, up 2, and now I have my triangle A and A prime, or A prime and A prime now, at the same location. And now all I need to do is rotate 180 degrees. About point A prime. Okay, so when I rotate that, now keep in mind my program won't allow me to rotate about a point. I have to rotate this 180 degrees like so, and then I need to move it up so that A prime is on A prime. And there is my triangle landing right on top. Okay, so if I wrote down answering this question right here, describe a sequence, I need to go back and look. Okay, so the first thing I did was I scaled it down a half. So I'm going to say that. So I would say scale by a factor of 1/2. That was step 1. Okay, and then I translate x, y to, and what was it? right 5 up 2. Right 5 up 2. And then finally, rotate 180 degrees about point A prime. Now I don't need to say clockwise or counterclockwise because rotating 180 degrees either direction puts you at the same location. Okay, so there's B. Now it says describe the sequence of a dilation followed by a congruence that proves A prime, B prime, C prime similar to A, B, C. Okay, so in this situation, I'm not going to go through all these steps again, but what they're saying is I did the easier one because we can do it on paper, but in this one, I might want to move it first. Actually, let's do it. Okay, so let me get all of this stuff out of the way. And we'll start fresh for this problem. Actually, I could still probably use that. Okay, let's get that out of the way there. Now I'm going to move this over to here. So just so I'm not going off the paper when I scale it up, how about I move my triangle first and then scale it up. Okay, so if I have triangle A prime, B prime, C prime, and I'll draw that. Okay, so the first thing I want to do here is move this triangle. So I'm going to do the translation first. So if I want to move C prime down so that it's right here, okay, what I need to do is determine where it came from and where it ended up, and that is my transformation. So C prime is at 4, 9. And it went to -6, -2. So it is going to be an x comma y. And I'm going to translate it to x. Now it was moved left, so it's negative. So I went from 4 to -6. That's a distance of -10. So it's going to be x minus 10, comma, y, and we're moving down, so it's going to be minus. And we move from 9 down to -2. Well, now 9 down to 0 is 9. Down to -2 is 2 more, so that's down 11. So there's my translation. I shifted the triangle left 10, down 11. So now my C prime is on C. And I realize that this line segment here is a straight line. So now I'm going to rotate 180 degrees. Rotate triangle A prime, B prime, C prime 180 degrees about point C. So if I rotate this 180 degrees about point C, remember this program will not allow me to rotate about a point, but if I just rotate it from the center and then move that up so C is on C, that's what a rotation of 180 degrees about C would be. And I know my scale factor is 2, so then if I double the size of this, then it will end up being right on this triangle. So then my last step would be a triangle A prime, B prime, C prime, scaled up by a factor of R equals 2. Okay. And then D, is it true that these triangles are similar? Is it true that triangle ABC is similar to A prime, B prime, C prime, and A prime, B prime, C prime is similar to triangle ABC? And why do you think this is? Okay, so the answer is yes, it is true. If triangle ABC is similar to A prime, B prime, C prime, and triangle A prime, B prime, C prime is similar to triangle ABC. This is true because when we say figures are similar, it means that they are the same figure, just a different size because one has been dilated by a scale factor. For that reason, if one figure, like triangle ABC, is similar to another, like triangle A prime, B prime, C prime, it must mean that A prime, B prime, C prime is similar to triangle ABC. However, the sequence you would use to map one of the figures onto the other is different. And as you can see up above, they are. Scaled it by a half, moved it right 5 up 2, and then rotated 180 degrees. The other one we moved it left 10, down 11, then rotated it 180, and then scaled it up by a factor of the reciprocal of a half, which is 2. Okay, exploratory challenge number 2. The goal is to show that if triangle ABC, which is right here, is similar to triangle A prime, B prime, C prime, and A prime, B prime, C prime is similar to A double prime, B double prime, C double prime, then triangle ABC is similar to A double prime, B double prime, C double prime. All right, so let me explain that again. What they're saying is if this is similar to that, and this is similar to that, then we can conclude that we can go direct, and that is also similar to that. Okay? All right. Describe the similarity that proves this triangle is similar to this triangle. All right, so the first thing I'm going to do is determine what I had to scale it up by. So if I say that R equals, and we're scaling up, so my numerator's got to be bigger than my denominator, so I want my primes on top, I will start with A prime, B prime over AB. And A prime, B prime is 6.3. And I divide that by AB, which is 2.1. Well, 6.3 divided by 2.1 is 3. I'm also going to do the other two. So if I do B prime, C prime divided by B over, or BC, B prime, C prime is 3. BC is 1, and 3 over 1 is also 3, so they're the same. And then finally, R equals A prime, C prime over AC. And A prime, C prime is 9. AC is 3. 9 divided by 3 is 3. So to get my ABC up to the size of A prime, B prime, C prime, I needed to scale up 3. Okay. And then once I do that, then I can determine they're similar. So the first thing I need to do is scale that up. So my A point is -1, 2. So my A prime equals my scale factor times my point A. So A prime is going to be at 3 times, and my A is at -1, 2. So my A prime is going to end up at 3 times 1, which is 3, -3, and 3 times 2, which is 6. So A prime is going to be -3, 6, which is right here, A prime. Then I'm going to do B prime, which equals 3 times B. So B prime equals 3 times the point B, which was -3, 1. So B prime is going to end up at 3 times -3, which is -9, and 3 times 1, which is 3. So if I go over -9 up 3, this will be my B prime. And then finally C prime equals 3 times B. Let's try that again. C prime equals 3 times C. C prime equals 3 times the point C, which is at -3, 0. So C prime is going to end up at 3 times -3, which is -9, and 3 times 0 is still 0. So I go -9, 0, and there is my C prime. Okay, so now I have connected those dots, and we'll see if it's the same. Okay, so where do I need to move these? Well, A is at -3, 6, this A prime, and it needs to get to -3, 11, so that is moving up 1, 2, 3, 4, 5. And we just proved they were similar by scaling it up and translating it. So then I would say my next step would have been to, we confirmed the scale factor, we found the points, so we scaled it up 3. So I'm going to say that, scale, triangle, scale, triangle, A, B, C, up by a factor of r equals 3, and then translate x comma y to x comma y plus, and we went up 5. So that proved ABC is similar to A prime, B prime, C prime. B says to describe the similarity that proves A prime, B prime, C primes similar to A prime, double prime, B double prime, C double prime. Okay. So what they want us to do here is prove that this triangle is similar to this one. So the first thing I'm going to do is determine the scale factor to get from here to here. So I'm just going to do it down here so I don't have to go back and forth back pages. So let me just erase this and this and this and all of this. Okay, so now I want to know what scale factor will get me from this red triangle here over to the double prime. So now I'm going to take, and I'm scaling down. So scaling down means that r is less than 1, so my smaller number needs to be on top. So I need the double primes up here and the single primes down here. Okay, so this is double prime divided by prime. Double prime divided by prime. So A double prime, B double prime is 4.2. And A prime, B prime was 6.3. Well, half of 4.2 is 2.1, and half of 6.3 is 3.15. But will this reduce? Okay, so it will, because 2.1 will go into both of these. 2.1 goes into 4.2 twice, and 2.1 goes into 6.3 3 times. So my R is 2 to 3. So it should be the same for both of these as well, but we're going to check anyway. So B double prime, C double prime is 2, and B prime, C prime is 3, and there was no reducing there. It is definitely 2/3. And A triple prime, C triple prime is 6, and A double prime, C double prime was 9. So 3 goes into 6 twice, 3 goes into 9 3 times. So my scale factor is R equals 2/3. Okay, so the first thing we're going to do is scale it down by a factor of 2/3. Okay, so my A double prime is going to equal 2/3 of my A prime. So A double prime is going to equal 2/3, and my A prime is at -311. So if I take 2/3 of -3, and the 3's cancel, I'm left with -2. And 3 will go into 2/3 of 11 is 22 divided by 3, which is 7, with a remainder of 1. So I'm at -2, 7 1/3, which is about here. That will be my A double prime. Let me use a different color. So again, I go -2 up to 7, and then about 1/3 is right here. A double prime. Okay, so B double prime is going to equal 2/3 of A. I'm reading my last problem here. B double prime is going to equal 2/3 of B prime. So B double prime is going to be 2/3 times the point B prime, and B prime is at -9, 8. So B double prime is going to be 3 goes into -9 3 times, so that's -3 times 2 is -6. And 8 times 2 is 16 divided by 3. Well, 5 times 3 is 15 with a remainder of 1. So that's going to be 5 1/3. So -6 up to 5 and then another third. So there is B double prime. And C double prime is going to equal 2/3 of C prime. So C double prime is going to be 2/3 of the point C prime, which is -9, 5. Okay, so C double prime is going to go in, 3 goes into -9, -3 times 2 is -6. 5 times 2 is 10, divided by 3 is 3 1/3. So I'm going to go to -6, up 3 1/3, and there is C double prime. Okay, so now that I've scaled that down to the same size as this one, now I need to move it. Okay, so if I move A to A, I've got to go down 1/3, 1 1/3, 2 1/3, 3 1/3. To get A double prime down here, I went down 3 1/3, so that's Y minus 3 1/3. To get A over to here, I went from -2 to 3. That's a right shift of 5. So this is my X comma Y translation. So XY is going to move right 5, down 3 1/3. So if I do that, and I go 1, 2, 3, 4, 5, and then down 3 1/3, well, there's a third, there's 1, there's 2, there's 3. So there is a shift, right 5, down 3 1/3. Okay, and then finally, I'm going to rotate it 90 degrees clockwise about point A double prime. So I'm going to rotate this, but A double prime, there's 90 degrees, but A double prime would have stayed on A double prime, and there it is. Okay, so there's the transformation to get the red to the green. So to recap, I scaled it down by a factor of 2/3. I translated it right 5, down 3 1/3, and then I rotated it clockwise 90 degrees about point A double prime. That is not the only way to do it. That's just the way I did it. Okay, C says verify in fact that A, B, C is similar to A double prime, B double prime, C double prime by checking corresponding angles and corresponding side lengths, and describe the sequence that would prove it. Okay, so again, now they want us to move this over to here. So that's our next step. So I don't need this anymore. What I need to do is move this to here directly. Okay, so let me just start fresh. And I'll be back in a moment. Okay, so now we're going to verify that I can go directly from A, B, C to A double prime, B double prime, C double prime. The first thing I'm going to do is scale it up. So I'm going to label my coordinates. A is -1, 2. C is -3, 0. And B is -3, 1. I want to scale it up. 3 to 6 is 2. I'm just saving some time here. That is times 2. 2.1 times 2. 1 times 2 is 2. It's a scale factor of 2. So my A times 2 is going to equal A double prime. So that's 2 times my point A, which is negative 1 comma 2, which is going to equal my A double prime. And 2 times negative 1 is negative 2, and 2 times 2 is 4. So there's my A double prime. So I go over negative 2, up 4, and there's where my A double prime will end up. And then I do 2 times B will give me B double prime. 2 times my B point, which is negative 3, 1, will give me B double prime. 2 times negative 3 is negative 6. 2 times 1 is 2. So B double prime is negative 6, 2. It's right there, B double prime. And then finally, 2 times C will give me C double prime. 2 times the point C, which is negative 3 comma 0, equals C double prime. 2 times negative 3 is negative 6. 2 times 0 is 0. So I go to negative 6, up 0, and there is my C double prime. Okay, so now I have triangle A double prime, B double prime, C double prime drawn up for you. And what we need to do now is get it over to here. All right, now I see that this would be a 90-degree rotation, but where am I rotating around? Where's my center of rotation? That'd be a 90-degree clockwise rotation would get me there. But if I do a 90 degrees rotation about the origin, the point negative 2 comma 4 would end up at 4, 2, and I'm still off a little. So let's rotate it first, 180 or 90 degrees. So if I rotate this 90 degrees and put A back where it was, which was negative 2, 4 is going to become 4, 2. So just to save time here, what happens is you rotate, when you rotate 90 degrees clockwise, your X and Y change positions and your X becomes positive. So X and Y change positions, I should have the point 2 comma 6. So I go over 2, up 6, and sure enough, there's B. And actually I'm down 1, so that should be 2, 4. So now I'm at 2, 4. And then 2, 6, and 0, positive 6. So there's a 90-degree rotation clockwise. So the first thing we did, so let's write this down. Step 1, scale triangle A, B, C up by a factor of R equals 2. Then rotate 90 degrees clockwise about the origin. And finally, we're going to translate. So let me just move this up. So as you can see, we're going to have to move this up 1, 2, and left 1. Okay, so left 1 would be xy is going to become, left 1 is minus 1 on the x, and up 2 is y plus 2 on the y. And we just verified that a direct A, B, C is similar to A double prime, B double prime, C double prime, which answered part D. Okay. That is the end of lesson 9. Review the summary and go to your problem set.